Hello, my name's John. I'm going to do a compact circuits mod demonstration. I'm going to start by putting one of the mini compact processors out, and I'm going to go into it. And I've made some models in advance. The first one is Demo 1 Slider and Checklist. I'm going to import that, and now I have this this set of inputs and outputs. This is our input and output pole. I'm going to name it light. That will be good. I'll name it light, and then you see we have three input components: red, green, and blue. And this is a toggle. Let's see what those do. When we exit the editor, we come out, and I'm going to control click to see what this says. And there's this little checklist. It says connect light. Okay, so let's find a light. Where are the lights? I have them under circuit components, and I'll put it here. I'll connect it. There's one of these that says light on it, so I connect it there. Then I'll control click again. It says connect. We've connected the light. Set always on. So I'll go to light, and over here is the always on button. So we can go back in here, control click. I've done that, and then set color components. So I'll come back over here and set use colors and color components. Now, what we can do with the sliders is we can move them back and forth and see that the colors change on the light bulb depending on what amounts of red, green, and blue we input. Any more notes on that? Just the fact that these are component type sliders. These little things here have several different options for input: text box, sliders, toggle, drop down, choose signals with counts, and long distance wireless router. All of these are accessible by that control click that you do on the external processor. Let's go on to our next demonstration. We'll go on to long distance wireless connections, and we will import that one and confirm the import. This says component type long distance wireless router. Its label is Roboport connection, and its connected channel is the Novice Logistics Network. This one over here is long distance wireless router. Its label is different, wireless receiver, and it says Fulgora Logistics Network. Right here I have a combinator that I don't think I'm using in this demonstration, so I'll remove it. And we can look at the text outside. This text says long distance wireless router demo, and it appears, since it's not internal, it'll show up outside. And this is our checklist. We will come outside the editor and hit control click. Now you see this is the label from inside. It says Roboport connection, and I had chosen Novice Logistics Network, but I can choose other things from outside. I can choose other things from outside of there. And the wireless receiver, Fulgora Logistics Network, but I can choose from outside the component. Our checklist is we need to have one Roboport connected to the red wire. We need to have connected channel named, and we need to have the correct Roboport connection selected by control click. Anyway, all those are little things that you can do with the logistics network. Anyway, what we have on the Fulgora network, you can see that I have started making lots of high quality ice cubes, 14,825 high quality ice cubes that I have on Fulgora. And then, but then you can come in here and click on the Gleba logistics network, and you can see what I have on Gleba in their logistics network. It looks like I'm storing quite a bit of iron and copper. This component here is display multi-signal, so you can see that I have set it to square left top, and it's showing me all of the, and if I did fix columns, it would come out just a big long line going down like that, and I can't even see it. Actually, if I hit M, I think I can scroll down, keep scrolling. Yeah, you can go into map mode and see the whole thing. All right, what else can we do? I think that's enough for this demonstration. Let's go on to demo 3. Demo 3 is text offset, and I'll just go ahead and this is I just wanted to show you just a little thing in this. This is a big complicated circuit that I was working on, but you can see here I've used this display component to display a set, but I've given it the offset 1, 1. So it goes 1 to the right and 1 down. And you can see that instead of saying filtered inventory on top of the component, it says filtered inventory down here on this, what's it called? It's an internal long distance pole. Now, the internal long distance pole will actually show you, let's see, is there one that actually has, yeah, here's one that has something on it. The internal long distance pole will actually have the signals on it. So here I've got stage recipes, but I've got the offset 1, 0, so it goes 1 to the right, and then I have stage recipes labeled right on top of that long distance, internal long distance pole. And so I just hover over that thing that says stage recipes, and you can see over on the right of the screen exactly what signals that pole has on it. Okay, that's all I really wanted to show you in this demonstration. So we'll just go on to the next one, and the last one, which is Demo 4, Meta Signals. And we will import that. And let's see, what do I want to show you here? I'm going to go outside, and I'm going to control click on it, because there's a few things that I want to show you in the notes. Well, first of all, let's set these to, we'll go the up arrow for the first input, we'll go the no entry for the second input, and we'll go N for the output. And let's see, we'll save that and then go back inside, and we'll see this combinator right here. It has up arrow times no entry for the first input, second input, and the signal N. And that is because I've used these. These are meta combinators. The first input comes from here, from the choose signals, which is the up arrow. The second input comes from here, choose signal, second input, from, and it's that null entry. And the output from the label output, max count of signals. Now I've put together several things that work. You can see that we've got what I have termed a real signal with a red circuit R, and wait a second, where's the, there it is, and a meta signal with a G from the green wire. The green wire is the meta signal, and the red wire is the real signal. So the real signals can come from or through other combinators. But this one, it fails because we've mixed the green signals together and they don't come out of the output there. This one fails because the meta signal can't pass to decider combinators. It might have worked in a previous edition where they didn't have multiple conditions for decider combinators, but in this version where you can add as many conditions to decider combinators as you want, it doesn't work. Let's see. You can send the real signals from constant combinators. Here's a red and a green and a blue going through just multiplying. What am I multiplying by there? Anyway, oh, this one fails because it's the wrong color. Because I'm sending green to red. Green, remember, is the meta signal, and red is the real signal. So you can't mix it. You can't put them together like that. This one works though, because the red signal is on the real signal, and then the green is on the meta signal. So red is the first input, red. Green is the second input, green, and blue is the last input, blue. So I can change, say, this one to Y, and you'll see this now says Y on it instead. So I'll turn that back to green. And I think that covers most of what I wanted to cover. This is I think it's a great mod. Took me a little bit to figure out what I have so far. There's still a couple of things I'm not sure about, but I hope this is a good video to explain some of the possibilities that you have with it.